Everyone, very good morning and welcome to the BYJU'S exam prep. This is Sanjay Rathi. Let me know that sound quality, picture quality, everything is fine. Yes, please. Now guys, already notification out for HPCL 2022 and paper. We are going, this is the notification for what? HPCL 2023. And as you know, papers are available. And that's why we are discussing the previous year question paper of HPCL 2022. Okay, and when we are solving this question, you will get the idea about exam pattern and how to solve the question. So stay tuned with us and subscribe the channel and like the session. But first of all, let me know that everything is fine. Okay, I think now everything is fine, guys. Okay, then this is the HPCL 2023 for electrical engineering and we are discussing HPCL 2022 paper. Okay, all questions, all technical questions we are going to discuss here. So Ashok, how are you? Then this is my introduction. Myself Sanjay Rathi. I am an ex-IES, 22 years of teaching experience and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ESE 2005, AIR 21 in ESE 2008. And I have trained more than 1 lakh students for these exams. And according to my experience, if you want to crack HPCL, then you have to solve the previous year questions. But with this paper, you will get idea. You have to focus on 1 mark question from GATE previous year question paper and you can solve what? Question paper of engineering services pre-examination, especially from what? Electrical branch, guys. You will get direct questions, but we have assertion and reason type of questions, match the following type of questions, and what number of statements, which statements are correct. No need to solve all these questions. Simple MCQ, as simple as possible. Okay, now I am going to start with what? Network. Then after me, Rakesh sir will join. So stay tuned with us and try to solve all this question with copy and what? Pen. Marks your answer whether you are giving the right answer or wrong answer, and at the last please check your marks also. Okay, this is a technical paper. Okay, then this is my Telegram channel. For more detail about this and PDF of this session, you can join my Telegram channel, that is Electronics by Sanjay Rathi. And for daily dose to improve the concept, for daily important questions, for latest information about the exam, for notification about the classes and PDF and notes and doubt clearing session by experts, you can join my Telegram channel. So please join it now. And then HPCL 2022 question paper. First question. This is the first question on what? Inductor. Okay, tell me what is the answer. What is the answer for this question? Two inductors, each having self-inductance of 1 Henry, are connected in parallel. Are connected in what? Parallel. In such a way that their fluxes act in same direction. Okay. If the mutual inductance is 0.5 Henry, then find the equivalent inductance of the parallel connection. Equivalent inductance of the parallel connection you have to find. Now tell me what will be the answer for this question. Then two inductors each having self inductance, guys. Then you can make diagram like this. Okay, these are the two inductors. And let this is the same direction. This is the L1 because value is same, LL. And then let this is I because these are equal. Then I by 2 that is divided here. Okay, then how we can write the equivalent diagram for this? Just then I will give you the shortcut. This is connected here. Right, now you can represent it by what? J omega L, and you can represent it what? J omega M into what? I2, that is I2 is nothing but I by 2. This is I by 2, and similarly you can represent it by what? J omega M, that is the I by 2 and that is I. Now what is the L equivalent? L equivalent is equal to, this is I total, and then you can write this is J omega L equivalent. Now from these two diagrams, this is I by 2, this is I by 2. Okay, then 1 minute. Okay, then guys, try to understand. This is the case. Now you can write, these are the two connection in what? Parallel. This is plus, this is minus. Now you can find the J equivalent from these two diagrams. When we are comparing these two diagrams, you will get L equivalent is equal to L plus M by 2. L plus M by 2. What is the value of the L? Question given L1, and this is what? 0.5 divided by what? 2. And that is nothing but 1.5 divided by 2, and answer is what? 0.75. Answer is 0.75 Henry. So this is the answer. So if two inductor of same value and mutual inductance with the same value, if they are connected, then directly you can say L plus M by 2. This is the connection in what? Parallel, and you will get the answer 0.75 here. So that is about the first question. Now you can also compare these two diagrams, write down the KVL from that point to this point and compare with this. Again, you will get the same answer for this questions. Okay, then compare the voltage. Compare the voltage in these two diagrams. Second question. So Ashok, that is clear to you? Then again, watch this. Determine the voltage at the node A and node B in the given network. Node A, this is the node A, this is the node B, and this is the with respect to ground. Again, this is a very easy, but try to avoid the silly mistakes here. You have to apply the KCL and KVL only. KCL and KVL. The first option is 3 volt, 11 volt, 11 volt, 3 volt, 11 volt, 11 volt, 3 volt, 3 volt. That is the answers A, B, C and what? D. Okay. Now, how we can solve this? Then, okay, try to give me the answer. What is the answer? Within 1 minute you can solve it. And then watch this question. This is 3 ampere. This is 1 ampere. So total current is what? 4 ampere here. And it will create a drop. 4 into 2, that is what? 8 volt. 4 into 2, that is 8 volt. Now this is the 4 ampere current. What is the current here? 3 ampere. So what is the current in downward direction? 1 ampere. Now this is with respect to ground. What is multiplied here? 1 into 3. So what is the voltage here? 3 volt. 1 into 3, 3 volt. So what is the VA? VA will become 3 volt. And then what is the VB? VB will become 8 plus 3. That is the 8 plus 8 plus 3. That is what? 11 volt. So VB is 11 volt. At this node 11 volt. At this node it is a 3 volt. That is second question. Yes. Ishwar, you have given the right answer. Very true. That is the A 3 volt and B is what? 11 volt. So yes, within 1 minute we can solve, or less than 1 minute we have to solve in exam. Within 20 seconds, this type of questions. Third one. Now third question. Find the current IM in the given circuit. Again, very simple network. Okay, try to give me the answer. Find the current IM. This is the 10 ohm, this is the 40 ohm. Simple, you have to apply the current division rule. But be careful about what? Direction of the current. Then answer is minus 4 ampere, minus 1 ampere, 1 ampere and what? 4 ampere. So within 20 seconds you can solve this question. This is 5. So what will be the current division rule? According to current division rule, this is I1 and that is I2. In this direction the current will flow. So what is the I2? I2 will become 5 divided by 10 plus 40. And if you want to find the current through the 40 multiplied with the 10. 50 divided by 51 ampere. But this is the value of I2. So what is the IM? IM is nothing but minus I2. Minus 1 ampere. Minus 1 ampere. So which answer is correct? B for Bombay. Okay, so that is also correct. So please mark your answer in your what? Copy. So that at the end you can find what is your marks in technical paper. Okay. We will solve around 80 questions from technical portion. 18 questions from network. So that is the third question. Now the fourth one. Guys, if you have cleared the UPSC Engineering Services Mains, or your friend cleared the Engineering Services Mains examination, because the result is out, then share your result and get the free mock interview with our expert panel. Share now. राइट जो भी आपके दोस्तों ने भी अगर इंजीनियरिंग सर्विसेज प्री एग्जाम क्रैक किया है या आपने क्रैक किया है, देन कॉन्ग्रेचुलेशंस एंड स्टार्ट योर प्रिपरेशन फॉर मॉक टेस्ट. रिमेंबर गाइस, व्हाट इज द मार्क्स? 200 marks. And what is the variation? One student can get 60 marks only, or one student can get what, 150 or 160 marks out of what, 200. So that is the range, that is the variation out of 200. If you want to get 150, nearly 150 marks, then proper mock interview and proper guidance is required. If you have cleared, then please register yourself for this session, guys. Okay, that is very, very important one. And if any friend, then please inform them about this session. Okay. Now, in a series RLC resonance circuit, please watch this question. In a series RLC resonance circuit, at resonance, the current drawn by the circuit is series RLC circuit, minimum, maximum, undefined, zero. By 10 seconds, only 10 seconds required to solve this type of questions. 10 seconds is required to solve this type of questions. Okay, tell me what is the answer? What is the answer for this question? Then, series resonance circuit. Series resonance circuit means this is R, this is L, and that is C. Okay, and in series resonance, this L and C will act as what? Short circuit. Combination of L and C will act as a short circuit. So we are having the Z minimum. What is the minimum resistance? R. And if this is minimum, then what about the current? Current will be maximum. Current will be maximum, guys. We are having this type of curve for impedance. So at this point, we are having the minimum impedance. At resonance, we are having the minimum impedance, that is R. And therefore, at this point, we are having the maximum current. That is the case. This is the maximum current at resonance. So this is the blue curve is for impedance of, and that is the black curve is for current I. Okay, magnitude of I. Yes, Avasya, we will try to arrange that session from instrumentation, because the number of subjects are common. So in a series RLC resonance circuit, at resonance, the current drawn by the circuit is maximum, because the impedance is minimum. So answer is B for this one. Okay, next question. Now tell me, with reference to the given phasor diagram, current I1 in the phasor is sum of. Watch this diagram carefully. This is the I1. 1 minute. This is I1 and 1, and that is the minus I1 dash, I0. So tell me, watch this diagram carefully. This is a parallel line. This is a parallel. This is parallel and that is parallel. Okay, so we are just finding the resultant here. So when we are finding the resultant, then what is the answer for this question? With reference to given phasor diagram, current I1 is the phasor sum of. Right, sir? Okay, so you are giving the answer C. So yes, this is the phasor sum of I0 and I1 dash. So which answer is correct? I1 dash and I0. It is visible in the diagram. Very simple question. So within how much time is required? 10 seconds, yes or no? 10 to 20 seconds. But try to avoid what? Silly mistakes. Right? No doubt, in last year there was no negative marking. And every question is of what? 1 marks. And you have to solve around what? I think 150 questions. Okay? So you have to solve. Sorry, 85 plus 85. Technical plus non-technical means what? You have to solve 170 question within 150 minutes. Within 150 minutes. 170 question within 150 minutes. You are going to get less than 1 minute for each question. Okay. Then tell me, an inductor of 0.1 Henry is connected in series with an inductor of 0.4 Henry. Right? Tell me then, what is the answer? Inductor of 0.1 Henry connected in series with inductor of 0.4 Henry. If the coefficient of coupling is 0.6, then find the mutual inductance between them. Find the mutual inductance between them. What is the M? Right? Then mutual inductance is given by coupling coefficient root over L1 L2. Coupling coefficient and root over L1 and L2. Then what is the K here? 0.6. And what is the L1 and L2? 0.1 and 0.4. 0.1 into 0.4, that will become, without calculator you can say this is 0.04. And what is the root of 0.04? 0.2. 0.6 into 0.2. What is the answer? 1.2. 0.12. 0.12. Because it is multiplied with the 0.6, so that is 0.12. 0.12. Which answer is correct then? C. So remember this formula. K is what? Coupling coefficient, guys. Here it is a coupling coefficient. So how many students are able to solve this question? That is easy one. Okay then. So this is the 0.12 Henry. Then next question is, super node is considered when there is a between two nodes. This is A here. Filling the blanks. Super node is considered when there is a filling the blanks between two nodes. Dependent current source, independent current source, resistor, or what? Voltage source. So when we are going to apply the super node, when there is in between these two nodes there is. Now guys, you can join this Telegram channel, that is BYJU'S Exam Prep Gate Electrical ECE and Instrumentation Preparation, for PDF and notes, and you can also put your doubts here. Okay, then tell me which answer is correct. Super node is considered when there is a between two nodes. D. Yes. Super node analysis means what? When we are having a voltage source between these two nodes, whether it is a dependent or independent, then we have to apply what? Super nodal analysis. For example, it is given as 2 volt. This is the V1, this is the V2. Then we are saying that V1 minus V2 is equal to what? 2 volt. And then we are applying the nodal analysis at 1, KCL at 1 and KCL at node number 2. So we are getting the equation. So we are considering these two nodes simultaneously. V1 and V2. We are applying the KCL at V1 and V2 at the same time with one equation, and that is called what? Super node. So remember, when there is a voltage source, then we have to use the super node. So which answer is correct? D. D is the correct one. Okay. So you have given the right answer, everyone. Now the next question is, so guys, within 10 seconds we can solve this question. 10 seconds required. But read question carefully and give the answer. Next one, a 20 millihenry coil is coupled with a coil of 5 millihenry. 20 millihenry coil is coupled with a, again we have the 3 questions. First question was what? On inductor. Again we have one question on inductor with coupling coefficient, and again one question on what? Inductor. Because it is electrical branch, so inductor is very, very important, and for electronics capacitor is important. So 20 millihenry coil is coupled with a coil of 5 millihenry. What could be the maximum possible value of the mutual inductance? What would be the 20 millihenry and 5 millihenry? This is the L1, this is the L2. Possible value of the mutual inductance. Tell me what will be the answer. K root over L1, L2. Then what is the range of the K? That is called coupling coefficient. 0 is less than K is less than what? 1. What is the maximum value of the coupling coefficient? That is what? 1. Right? So this is called tightly coupled and that is the ideal value. If the value is greater than 0.5, this is called tightly coupled. If the value is less than 0.5, then it is called loosely coupled. Loosely coupled. Right? And here it is called tightly coupled. Tightly coupled. Okay. So it is what? 1 means what? You can take the ideal value K1. So what is the root of the 20 and 5? 20 into 5, that is what? 100. And what is the root of the 100? 10. 10 millihenry. Which answer is correct? A is the correct answer. A is the correct. Iswar, you are giving the B. How you are getting the 20 millihenry? Okay. So this is the case, geometrical mean of L1 and L2, and what is the coupling coefficient K? That is what? Equal to this value. Okay then. It is asking about, not asking about the overall, it is asking about what? M. What is the mutual inductance only? Then so guys, you can join our BYJU'S exam prep. You can download now from Google Play Store. Okay. And number of notes, contents, free PDFs are available. You can also join the regular courses there and get the detail about all these on our BYJU'S exam prep app. So download it now. Then guys, next one. If the percentage reactance of an element is 20%, percentage reactance of an element is 20% and the full load current is 40 ampere, then the short circuit current will be, what will be the short circuit current? So that is actually, this is the question from what? Power system, but it is a standard question. So what is the answer for this one? If the full load current is given, then the short circuit current will be, so what will be the short circuit current, guys? Okay, give me the answer. You have idea about that. Short circuit current is given by full load current upon what? Percentage reactance of an element. Then percentage reactance divided by 20 upon 100. So it is 100 is multiplied here. And that is what it will give you the idea about the short circuit current. Means you have to write in what? Reactance in what? Simple in points. So 20 divided by 100. So you will get this answer. So well, okay. So which answer is correct? So what is the full load current? 40 it is given, divided by 20 into what? 100. So this is cancel out. This is the 20 into 10. That is the 200 ampere. 200 ampere is the answer for this question. That is the question from power system. Now, next one, Mohammed. Yes, you have given the right answer for this question. Next question. Mesh cannot be defined for network. Mesh. So when we are applying the mesh analysis, means this is called mesh. So we are giving the mesh current I1. This is called mesh independent loop. This is called I2. Right? And these are called mesh current R1, R2, R3. And then we are writing the KVL. Right? So that is called mesh current I1 and I2. It is possible for yes, time invariant, planar network, but it is not possible for what? Non-planar network. This is the A is the answer for this question. Non-planar network. When we are having the branch crossing that, this for example, we are connecting the one branch from this point to this point, but if we can remove that branch, then it is what? If suppose one branch cross the another branch, that type of network is called what? Non-planar network. So non-planar network, it is not possible to write the mesh, right? And that is the mesh cannot be defined for non-planar network. That is the answer. Okay then. Then next one. Find R equivalent in the given circuit. So what is our purpose, guys? With this paper, you will get idea which type of questions they will ask. 50% theoretical question, 50% question numerical based in case of network. But in core subject, normally we are getting theoretical questions. Okay. So stay tuned with us so that once you will solve 80 questions, you will get the idea about the paper. Then find R equivalent in the given circuit. What is the R equivalent in the given circuit? Simple equivalent resistor you have to find what is. So 28 and 52 are in series. So 52 plus 28. Right, that is nothing but 80. Now this 80 and 20 are in parallel. $80 and $20 are in parallel. So always remember, you can check 10 as a common. 2 into 8 upon what? 2 plus 8 into 10. So normally if you can take any factor common, you can also take the HCF, that is the highest common factor. You can also take 20. Then it will become 2 into 8 upon 2 plus 8. 8 into 16, that is the 16. Directly the answer is 16 ohm. Now 16 plus that 25, 15 and 25 plus 15 is what? 40 and plus that 16 is what? 56. 56 is the answer. 56 is the answer, guys. Okay, so this is the case 15, this is 25 and that is the 16. So what is the R equivalent? 56 ohm. So this type of questions we are getting. Okay, see 56 ohm. Yes, that, yes. Non-planar means yet, Muhammad, yes, we can draw, can't draw it on what? 2-dimensional. It is a 3-dimensional figure. Okay. Then, next one. So, this is the workshop by Abhinav Negi sir. Please note the date on 23rd of August at 12 p.m. means today. At 12 p.m. just after the session, you can join by Abhinav Negi sir. And workshop 5 tips for 100% execution of the gate preparation strategy. And you can also ask your doubts. And guys, second one, this is a golden opportunity for you. If you want to start your journey with us, then give the national scholarship test. And on 27th of August means coming Sunday. And what is the time? 9 a.m. to 9 p.m. Means total 12 hours. The window will be open. So try to give and get the idea about that. And avail 90% off on our program. And you can start your journey with us. Okay, please note the date. Then next question, find the current I in the given circuit. What is the current I in the given circuit? Again, very easy question. 100, 400, 300. So tell me 100, 400, 300. What is the equivalent? 400 plus 300 plus 100. And that is the 12. And that is the right direction it is given. Right direction it is given. Now, what is the I is equal to 12 divided by R equivalent, and 3 resistors are in series. Tell me what is the answer? 100 plus 400 plus 300. So that is 12 divided by 800. And then when it is divided by the 4, this is the 3 divided by 200. So 3 by 2, what is the 3 by 2? 3 by 2, 1.5 divided by 100, 0.015 ampere. 0.015 ampere. Which answer is correct? A. So sometimes we can do the silly mistakes here and you can write the answer 0.15. Please try to avoid the silly mistakes. The answer is what? A. Then very easy. Find Vm in the given circuit. What is the Vm in the given circuit? Means voltage. This is the voltage Vm. And here it is what? 75. Oh, my dear friends, it is again a very easy question. Simple voltage division rule. What is the value of the Vm? 8 volt it is given. So this is a resistor. This is a resistor and 8 volt. Answer is 4, 2, 8 and 6. So what is the voltage division rule? This is R2, this is R1 and this is the Vs. So what is the voltage across that? Vm is given by R2 upon R1 plus R2 into Vs. So what is the R2? 25 upon 75 plus 25 into what? 8. That will become 8 by 4, 2 volt. 8 by 4, 2 volt. That is the answer, 2 volt. Yes, B. B for Bombay. 2 volt is the answer. So देखिए, देख रहे हैं आप, Simple current division rule, voltage division rule, find the R equivalent, find the current. That is the question, level of the question, guys. Then next one. Next question. Okay. 13th question, guys, we are going to solve this. If a circuit load impedance is 25 minus J25, impedance is given 25. Tell me whether it is an inductive impedance or capacitive impedance. Z. 25 minus J25. 25 minus J25. So it is if a circuit load impedance is, then find the power factor. Remember, it is a capacitive. It is what? Capacitive reactance. Okay, total. This is the resistance and that is what? Capacitive part. This is the value, R minus J omega C. Now, what is the phase of that? Magnitude you can find, an angle. You can represent like this. So what is the phase of that? Tan inverse of 25 upon 25, that is what? 45. Minus 45. This is the phase of impedance. Then what is the power factor? Power factor is nothing but cos theta. And what is this theta? That is the phase difference between what? Voltage and current. Because when we are finding the current, it will become V by Z. So that is the V by Z theta Z. And it will become what? Positive. And current leads the voltage. Because here it is in denominator, it is negative. In numerator, it will become positive. So current leads the voltage. That's why it is a leading. And it is a capacitive. So leading circuit. And what is the cos theta? Cos 45. Cos 45 means 1 by root 2. And what is the 1 by root 2? 0.707. 0.707. Yes, you can find directly, you can find the value. Only the magnitude is required, leading or lagging not asked, but remember, this is important topic. D. Next one. In a simple coplanar network, there are 7 branches and 4 junctions. 4 junction means what? 4 nodes. 7 branches, B7, node 4. How many mesh currents are required for the solution of the network? How many mesh currents are required for the network? Okay, so that is the equation, basics of the network. Then mesh current means we want independent loops. So how the loop? L is equal to B minus N plus 1. N is equal to B minus N plus 1. That is the question. Okay. So, chaliye bataiye what will be the answer? What is the answer for this question? Okay, give me 1 minute. Okay. Now tell me what is the answer, guys? A. Yes. So this is the case. How many branches? 7 branches. 4 junctions plus 1. So 7 minus 4, that is 3 plus 1, that is the 4. 4 is the answer for this particular question. Okay? The solution of the network, it is required. Then, hello. Is it audible? Okay, I think now everything is fine. Then guys, if you want to start your journey with us, then already we have started our courses, Vision Gate 2024. That is the course for what? electronics aspirants, complete syllabus coverage with live classes, recorded lectures, right? Study materials we are providing, practice quizzes we are providing, and most important one is what? Mock test we are providing here. So you can join for electronics. Similarly for electrical, all faculties are highly qualified and experienced, and you are familiar with them, right? The Saket sir, Asu Jangra sir, and MN sir, Rakesh sir, and myself Sanjay Rathi. Then this is a Vision Gate 2024, a course for GATE electrical aspirants, complete syllabus coverage with all facilities, live classes, recorded lecture, study material, mock test. देखो, remember national this what? GATE exam and what? Engineering services exam or national level exam. Again HPCL. Right? If you want to crack all these exams, then systematic preparation is required. Then you can join, and for more detail, you can call at this number. You can call at this number, and you can book your time for what? Free counseling also. Okay then. Then tell me, for a series RLC resonance circuit, 2 half power frequencies are 36 kilohertz and 25 kilohertz respectively. Find the resonant frequency. What will be the resonant frequency for this series? Again, we have one question. We have solved one question on series resonance. And again, there is another question on series resonance. Tell me what will be the frequency here. 11 kilohertz, 20 kilohertz, 36 kilohertz, 30 kilohertz. 36 is the upper cutoff frequency and 25 is the lower cutoff frequency. Then, what is the resonance? Watch this. Now, okay, then the frequency at which current will become maximum divided by root 2. This is called lower cutoff frequency, and this is called upper cutoff frequency, 36, and that is what? 25. So what about the resonance frequency? In between this, that we can find the value. What is the answer for this question? 30. Answer for this question is what? 30 kilohertz. This is the answer, right? Suppose if the bandwidth is asked, bandwidth is what? Remember the formula, FH minus FL. Higher cutoff frequency minus lower cutoff frequency. And the bandwidth is given by F0 by Q. If the quality factor is asked, then you can find the quality factor also. Okay, so that is the case, guys. Okay then. So by watching the answer, you can give which one is in between the 36 and 25. Directly 36 and 25, no need to draw the diagram directly. You can say what is the answer? 30 kilohertz. What is the answer? 30 kilohertz. Okay. Or otherwise you can find the mean of that. 36 and 25, you will get the answer 30 kilohertz. Geometric mean. Then next question. Find the voltage at node B in the given circuit. What is the voltage at node B? Tell me. At B, what will be the voltage? Very negative. There are three nodes A, B, C. This is the 2 ampere current source. This is the 10 volt it is given. This is the 12 volt it is given. This is the 5 ampere it is given. And we are saying that we have to find the voltage across A, voltage across B, voltage across C. But what is asked here? That is important. Voltage at node B. So we are finding the voltage with respect to what? Reference or with respect to ground. So what is the voltage? Watch this. This is a negative value. Watch it carefully. This is a negative value. This is positive one. So directly we can say at this point what is the voltage? VB minus 12. So no need to find the voltage at C, no need to find the voltage at A. Directly you can say it is a minus 12 volt. That is ours. So B is the answer. तो आपको लगेगा ना एग्जाम मेरी इतना इजी कैसे आ गया? And we will waste our time. Again we will check 2 to 3 times. Yes, Mohammed, that will be the problem. If suppose you are इतना easy कैसे ये to only minus 12. So remember you have to solve 170 question in 150 minutes. Within 150 minutes, 2 hours, 30 minutes. And that's why we will get this type of questions. Okay. Then last question from the network, then the Rakesh sir will join you. Okay. So what is the answer? Find the current I in the given circuit. Find the current I in the given circuit. 80 milliampere, 8 milliampere, 32 milliampere, and what? 16 milliampere. Again, these are the resistance 600, 150, right? And then this is the 500, that is the 200, and 40 volt it is given here. 40 volt it is given here. Then you have to find the value, right? You have to find the value of the current I in this branch. In this branch, what will be the value? You can find the R equivalent. Then you can use what? Current division rule. You can directly apply the mesh analysis, or you can apply the nodal analysis. So which one is easy, you can apply here. Okay. Then tell me, what is the answer? What is the answer for this question? Okay, try to solve this one. So ready? Last. One minute. Find the current I in the given circuit. Find the current I in the given circuit means what? 80 milliampere, 8 milliampere, 32 milliampere, and what? 16 milliampere. Then simple 600, 150, that is what? Nothing but 750. 750 parallel with the 500. Then you can find the R equivalent plus what? 200. So it is nothing but 200 plus 500 parallel with 750. Okay. Then guys, and you will get the answer. Then 40 divided by that R equivalent. What is the current given by this I? I is given by 40 divided by R equivalent. And then finally you can apply the current division rule. So what is the I is equal to? I is equal to, it will become I divided by 500 plus 750 into what? 750 into 500 into 500. This is called current division rule. So with this help of current division rule you can find, and then what will be the answer? You will get 88, 32 or 16 milliampere. What is the answer, guys? So Ishwar, you are getting here 32 milliampere. Easy questions. So, or you can apply the nodal also. Find the Vx minus 40 divided by 200, Vx minus 500. You can also use the concept of what? Linearity also. So you can go for what? Concept of linearity directly. You can assume this current as a 1 milliampere, 1 ampere. Then what is the voltage at this point? 750. 750 divided by 500, right? And then again you will get the current here in this branch. And then you can apply the concept of linearity. So I am going to take one session on that. Now quickly the Rakesh sir will join you. So don't leave the session. Within 15 seconds the Rakesh Talreja sir will continue with subject. Okay. So give me 1 minute only. Don't leave the class.
Welcome back to the session, and yes, we are having the HPCL 2022 complete previous paper discussion. As you know, very recently HPCL announced the recruitment for the 2023 once again through the separate written examination, and we have already talked about the strategy for the exam. We have already talked about the detailed notification, and okay, now we are discussing for the electrical engineers. For the electrical engineers, all technical questions, and you know how many technical questions were there last year? 85 questions. So 85 technical questions were there, 85 aptitude questions were there. This was the HPCL 2022 pattern. Okay, so let's get moving ahead. Some of the questions have been discussed already by Sanjay Rathi sir. 18 questions discussed. Let's move ahead. I'll be taking some questions of EMFT. Okay, now, and very simple, extremely simple and direct questions of EMFT you can feel here. Okay, so yeah, okay, so whatever we discussed today, the question solution, I'll share my portion, that is the EMFT, okay, in my Telegram group, whose link is written here. So you can join my Telegram group with the link attached here. Okay, and not only the today's class PDF for daily doses and for clearing the doubts by experts and your friends, important notifications and updates about the latest examinations like HPCL and others. All right, guys. So here it is, question number 19. Let's continue. Most of the questions are direct. Most of the questions are direct in nature. Okay, so quickly again share the session with your friends. Ampere circuit law involve finding what? Ampere circuit law, integral H dot dl over a closed path is equal to current enclosed by the path. Is equal to current enclosed by the path. So it is, okay, involves finding what? The total current enclosed by a closed path. It's a closed path integral, option number A. Okay, it is the option number A. Very direct statement. And there are multiple questions like statement only. Number 20. Identify whether the given statements are true or false. Okay, so something related with material property. Okay, you can put it in material science also or EMFT, but just one or two questions were of that nature. So I'm discussing it here only. Electric susceptibility is unitless. Okay, for any linear material, polarization, is the electric susceptibility, okay, multiplied by the field strength, and hence you have P by E, which is a unitless quantity. This is definitely true. Okay, but we define this electric susceptibility, the polarization proportional to field intensity for linear materials, but for ferromagnetic materials, you must have studied the hysteresis, right? Okay, if you relate with this, you should know that the relationship between the polarization and field intensity is non-linear, because ferromagnetics are class of non-linear only. Okay, so second one is also true. It is non-linear. Yes, it is non-linear. Aishwar and Ashok, please correct it. The answer is D. First and second both are standing to be true. Both are true. Even for ferromagnetic materials, it's going to represent a non-linear relation only. So the statement becomes true actually. The statement becomes true. Right? Chalo. Done, G. Moving ahead to the next one, 21. Find the divergence at the origin if D is given to you. Okay, D is given to you. Divergence of D. It's just like fundamental Gauss law. You can say rho V is equal to del dot D. Correct, Ashwar? Now, rho V is equal to del dot D. So we need to find out divergence of D, and which is nothing but rho V. See, they're not asking rho V. Okay, but yeah, that's what we should know. So what is the divergence of this vector now? Okay, del by del x of the x component, e power minus x sine y, that is the x component. Del by del y of the y component, what is the y component? Minus e power minus x cos y, plus del by del z of the z component, which is 2z. So this is turning out to be differentiation with x, so minus e power minus x. Okay, minus आ जाएगा. Cos y का differentiation is actually minus sin y, तो minus minus plus only, e power minus x into sin y, plus del by del z of 2z is going to be 2. So actually the first two terms just cancel each other and the answer is 2. So even at origin also, they have mentioned calculate at origin, but even if you calculate at origin as well, okay, the answer is just a constant only. So correct answer is option number C. Right, dear? Correct, Muhammad Suban. The very correct answer is option number C. Moving ahead to the next. Okay. Infinite uniform line charges of 5 nanocoulomb per meter. Okay. 5 nanocoulomb per meter lie along the positive and negative x and y axis in free space. They are infinite uniform line charges. That is why they lie along the entire positive to negative x axis, entire positive to negative y axis. Find the electric field intensity at 004. This is just little bit calculative. Very small calculation will be involved here. Okay. Okay, say this is the z-axis, y-axis and the x-axis. What they are telling you is infinite line charges of 5 nanocoulomb per meter lie along the x and y-axis actually. lie along the x and y axis respectively. Okay, say one of them is this, and say this is the next one. Okay, both of them are having the charge density of 5 nanocoulomb per meter square. This also has 5 nanocoulomb per meter square, but you are required to find the magnetic field, electric field at the point on the z-axis 004. At the point on the z-axis 004, this is the point of interest, point of observation. Let me tell you, 004. Okay, now guys, just to quickly recall, so if this is any uniform, if this is any line charge, infinite line charge, a very long line charge, okay, carrying some charge density rho L, that is in coulomb per meter, charge per unit length, charge per unit meter, and say this is the point of observation which is located at a certain distance. Okay, so and suppose that perpendicular distance is rho, then at this point of observation, the electric field is given by the formula rho L upon 2 pi epsilon rho. Suppose considering it free space, nothing is mentioned, to 2 pi epsilon naught rho A rho. Okay, where A rho is the perpendicular direction. Okay, unit vector. Okay, in the perpendicular direction from the axis of the wire. That is what is the general formula, and rho is that perpendicular distance. Okay, so if we just apply this formula here, the electric field at the point P, first of all, applying the superposition, okay, it should be E1 plus E2 because there are two sources. Now let's consider this source first. Y-axis wala le lenge. Okay, let us say this is the first one. Let us say this is the second one. So due to this y-axis point, what is the formula? Rho L. Rho L is equal to 5. Okay, rho L is equal to 5. Achha. Let us also simplify this. 1 upon 2 pi epsilon naught. What is the value of this? Okay, I'll write it as 2 upon 4 pi epsilon naught, and we should always remember either you remember epsilon naught value, that is also okay, but directly 1 upon 4 pi epsilon naught, the K of the Coulomb's law, and you can directly put it as 9 into 10 power 9. Okay, 9 into 10 power 9. Okay, so this is what is the value of 1 upon 2 pi rho epsilon naught. So isko humne kitna rakh diya? 18 into 10 power 9 rho L divided by rho A rho. Okay, so kitna ho jayega? Wapas aa jate. So this is going to be 18 into 10 raised to the power 9. Separate. What is the rho L? 5 nanocoulomb. 5 into 10 power minus 9 divided by what? Divided by the rho, the distance. Now what is this perpendicular distance? This is equal to how much? Okay, 4 units. This distance is equal to 4 units. Okay, now what is that perpendicular vector? Agar ye vector banana chahe, right, what is going to be the vector till this? Whether you are going from x-axis or y-axis, but you are going towards a point on the z-axis. So this direction is along the positive z-axis. This direction is along the positive z-axis. So what is the arrow? Okay, this becomes the arrow for both of the lines. Okay, that is AZ for both of the line. Okay, so this is also in the z direction. Next one, same value, 5 into 10 power minus 9, and same distance 4 in the z direction. Okay, right. So now this is simply equal to what? 18 into 10 power 9. 10 power 9, 10 power minus 9 cancel kar diya. Okay, then 5 divide by 4 and add it twice. So into 2 kar diya AZ. So hence my answer is equal to how much? This 2, 9, 9, 5, 45. 45 AZ should be the answer. Let's check out. The 45 AZ should be the final answer. The 45 AZ, option number D, is very much correct. Clear, dear? Option number D, 45, is the very correct answer. Moving ahead to the next one. Just a second, guys. Chalo, theek hai. Next question. Which of the following material offers the largest value of the dielectric constant? I think there is some issue with the pointer here. Okay, largest value of the dielectric constant. Okay, so again, I told you that some questions are directly factual based related with the material science knowledge. Okay, but yeah, still, let's look into it. Silicon, approximately 2.4. Okay, for paper, it is normally in the range of 2 say 2.5. Okay, for regular paper, again, it depends on the density of the paper as well, but this is what is the answer that you can take. For air, we all know it is approximately 1. Okay, and Teflon, it is approximately 2. So highest we'll put it for silicon actually. Okay, for silicon, because paper ka bhi range mein hota hai, we can take it as around 2 only for a regular paper. Okay, next question guys, number 24. The equipotential surface in the potential field of a point charge, okay, are the point charge that is dash centered at, यहाँ पे कुछ typing error है. Let me just check the actual paper. There is some typo issue. The language is not good. Okay, just a second. Language is not perfect here. I'll check it out. I have that original paper. कुछ तो यहाँ पे issue हुआ है. Just a second. The equipotential surfaces in the potential field of a point charge, okay, are dash centered, okay, of a point charge, are dash centered at the point charge. Yeah, now this makes a meaningful statement. This makes a meaningful statement. So what is the equipotential surfaces in the potential field of a point charge? Okay, a point charge. Tell me guys, okay, if there is a point charge, okay, if there is any point charge, suppose Q, okay, and I take any point of observation P at a particular distance R, at some particular distance R, what is the potential at the point P? We know it is given by the formula, simple formula, Q upon 4 pi epsilon naught R due to the point charge, or we can simply call it as KQ by R, where K is 1 upon 4 pi epsilon naught. So it is directly a function. It is directly inversely related to R. Clear? That means now, okay, if this is any point charge, let me take up this. If this is any point charge, and suppose point charge is located at the center of a sphere. Suppose the point charge is located at the center of a sphere. Now you calculate potential at any point on the surface of the sphere. At any point on the surface of the sphere. Okay, what is going to be the potential? Suppose this is the point P, right? It is given by KQ by R. Now, the distance from the center पे क्या है charge? The distance from center to the circumference is always fixed. That is equal to radius. Radius of the sphere fixed रहेगा. So that is when you calculate the potential at any point on the surface of the sphere, right? It is equal to constant. It is equal at all the points on the surface of the sphere, right? So what is the equipotential surface here? What is the equipotential surface here? Okay, the equipotential surface will be representing the sphere whose center is the point charge. The spheres which are centered at the point charge. Got it, everybody? The spheres whose center is at the point charge. Chalo. Next question, dear. Moving ahead to the next question. Okay, here it is. 25. The divergence of the, again, a basic definition coming up here. The divergence of the vector flux density A. Okay, you can again relate it, understand it, as you understand the Gauss law or the volume charge density, whether it is the flux density A and D, kuch bhi bol denge. Okay, it is the outflow of flux from a small, closed or open, definitely closed. Okay, you can recall from the Gauss law concept as well. From a small closed surface, okay, per unit volume, okay, outflow of flux coulomb per unit volume, because what is rho v? Rho v is given by coulomb per cubic meter. Okay, so it is the outflow of flux, okay, per unit volume, as the volume is small, that is volume shrinks to 0. Option number A. Option number A. Basic fundamental definitions. Okay, these are basic fundamental definitions. यहाँ पे कोई one or two questions you found some calculations, but mostly it is then fundamental definition based question. What will be effect on the force between 2 point charges if the distance between them is halved? If the distance between them is halved, Very fundamental question based on Coulomb's law. Suppose these are the 2-point charges, Q1, Q2, separated by a distance r. The force between them, the electrostatic force between them is given by K Q1, Q2 divided by R square. Okay, so if the distance between them is halved and the charge on both the particles is kept constant. Okay, it is kept constant. So if the distance is halved, okay, suppose isko F1 bol diya and this is R1. So what is going to be F2? Okay. Yeah, you can put it this way also. K Q1 Q2 divided by R square. So we know that this electrostatic force is proportional to 1 by R square, inversely proportional to R square. So R ko half kiya, right? 1 upon R will double, 1 upon R square will become quad, 4 times. Okay, so it should be what? 4 times. It should be the 4 times. Very, very clear. Very, very simple question. Okay, it should be the 4 times, right? Okay, option number B. Okay, directly option number B. Next one. 27. Again a definition. Polarization is defined as what? Dipole moment per unit volume. Option number D. Polarization of a material is defined as the dipole moment per unit volume. Okay. Chalo next. The electric flux passing through any closed surface is equal to the total charge enclosed by the surface. What is this statement? Again a statement and theorem question. The electric flux passing through any closed surface is equal to the charge enclosed by that surface. The direct version of the Gauss law. Option number C. I mean, these are just read and answer. Okay. Yes, Ashok. This is just like read and answer. Okay. Read and answer. Next. 20. Okay. Yeah. Before I go to the next, guys, some important announcements for you. Once again, that yes, on this Sunday, that is 27th of August. Okay. From 9 a.m., you get a chance to win avail up to 90% scholarship. Okay. Just have to prove yourself by appearing in this national scholarship test, and you can participate and get up to 90% scholarships based on your marks and percentage. And also, guys, 23rd August, that is just today. That is just today at 7:30 p.m. Right, all your favorite Abhinav Negi sir is going to come live with a free interactive workshop. Okay, with a free live interactive workshop at 7:30 p.m. At 7:30 p.m. Okay, and he's going to give you 5 crucial tips for 100% execution of preparation strategy. Okay, so all GATE 24 students can definitely attend this. Now, next question. Again, guys, a question coming up in terms of rho v. The volume charge density rho v is measured in, ये तो हमने discuss भी किया ना indirectly. It is measured in terms of coulombs per cubic meter. Okay, coulombs per cubic meter. Option number B. Okay, it is measured in the form of coulombs per cubic meter. It's option number B. Again, as direct as it could be. Okay, question number 30. Which of the following option gives the correct correlation, okay, between the variables of rectangular and cylindrical coordinate systems? X, Y, Z to point transformation formula. Point transformation formula. X, Y, Z to rho phi Z. X, Y, Z to rho phi Z. We should directly know this formula. ठीक है. अच्छा, sorry. X rho phi Z to X, Y, Z. इसी वर्षा बोल रहे. Rho phi Z to the X, Y, Z. So what is X? X is given by what? It is given by rho cos phi. Y is rho sin phi. Z is Z. Right. If they asked reverse, the point transformation from the Cartesian to cylindrical, X, Y, Z to rho phi Z. Okay, so वो भी लिख देता हूँ. Rho will be nothing but root over of x square plus y square. Phi is given by tan inverse y by x, and we know z is z. Z is common in both the coordinates. Okay, so the reverse also could be asked. So here rho cos phi, rho sin phi, and z. Option number B it is. Correct hai ji? Option number B. Rho cos phi, rho sin phi, and z equal to z. Moving ahead to the next question. Okay, number 31. Here it is. Okay, and yes, guys. Right. So now, if we're looking towards the next step towards success in GATE, the BYJU'S exam prep has the different courses for you right now. The Vision GATE course is available. Okay, a course for ECE as well as EE aspirants and other branches. Of course, the courses are available to have your complete comprehensive syllabus covered for GATE 2024 with live classes, practice question, recorded lectures, study material, mock test, everything like comprehensive. You don't need to worry about any other thing. Okay, you get even the practice books. Okay, delivered for you in study material, study notes, everything. Okay, and now this is the best faculty team. As you already know, you must have seen their lectures on YouTube. So you can enroll for the courses if you want. You can get the complete details on the BYJU'S exam prep app. How many coordinate axes mutually at right angles to each other are set up in Cartesian coordinate system? Okay, many of the questions are just like a joke. Many of the questions are just like a joke, right? Okay, how many? How many? X, Y, Z. Cartesian coordinate systems has 3 mutually perpendicular coordinates, that is X, Y, Z. Option number A. Option number A. 32. In a magnetic circuit for a coil having a single turn, okay, the flux linkage is equal to, okay, higher the more the number of terms, more will be the flux linkage, because the total flux link, okay, which we normally call this as lambda, is given by n into xi, where xi is the flux link through a single turn. Okay, through a single turn. Okay, this is total, and this is, okay, this is through single turn of any wire. Okay, so whenever there is a single turn, n is equal to 1, the total flux or the flux through a single turn will be same. Will be what? Will be equal to the same. Okay, so that is equal to what? That is nothing but total flux. That is nothing but the total flux. Okay. Okay, now guys, a very important observation. A very, very important observation is that that in the EE HPCL paper, okay, questions were mostly of core areas. Okay, now network and EMFT is definitely a very foundation for electrical. That is why there were the questions from network and EMFT, because you can count it again as the core part. Okay, but what I mean to say is there is no signal and system, there is no control systems and etc. Okay, no digital logic, even no analog circuits. Okay, rest part is pure core area. Okay, so you're not done with network and EMFT, and as you saw, EMFT was very simple. I think just one question required some calculation, rest was nothing. It is just simple as it could be. Okay, so now Ashu Jhangra sir is going to join us, and sir is going to take up the power electronics and power system, the very, very core areas. Hello? Sir, I'm done. तो ठीक है सर, लाइन पे रहिए, बच्चों को मैं बोलता हूँ, जस्ट लाइन पे रहिए. Yes, guys, so Ashu sir is joining live with, power system, power electronics, and then Naveen sir, machines and measurements. So rest, all of the questions are totally core. So just stay tuned. Within a minute, Ashu sir is going to come live. Hello. Sir, stop करूँ? ठीक है, ठीक. शशिकांत पे होगा सर. ये कॉमन सेशन सारे उसी पे बनते हैं ना आजकल. ठीक है, ठीक है, आप बता देना, क्योंकि वो गलती से भी आगे पीछे हो गया ना तो सेशन बंद हो जाएगा. तो आप लाइन पे रहिए. ठीक है, जब तक मैं स्क्रीन पे आता हूँ. Yes, guys. Okay, just few seconds. Ashu sir is joining with you. Okay, in case you had any doubts, please you can let me know by that time. Although it was a very, very simple, discussions of EMFT, all questions direct. Okay, केवल एक calculation था, that was also line charge, the field due to a line charge. That's also simple for you.
Sir, I'm ready.
Ready? ठीक है sir. Okay, guys, just 10 seconds now.
Hello everyone. Hello guys. Please tell me whether my audio and video is clear or not. Is it clear? Am I audible, everyone? Everyone, please reply. Am I audible? Am I audible?
Okay, thank you. So good afternoon everyone, and I hope you are enjoying. So let's start with the other subjects. So I will cover power electronics and power system. Okay, so I think it's time to start. So guys, this is my introduction. My name is Asu Jangana and I teach almost every subject in electrical engineering. You can start your preparation with me. This is my Telegram link. Okay, so the link is also given in the description, so you can join this Telegram link and you can connect with me for your doubts and for your queries. Okay guys, so I think it's time to start. The questions are very simple. Questions are I have some 20-25 questions or maybe 27 questions, and you will see that within 10 seconds we can attempt each question. Okay, each question will take almost 10 to 20 seconds. Now look at this question. It's a memory based question. So you have McMurray half bridge inverter that is blank commutated that blank source. So obviously it's a voltage source inverter. We know that McMurray half bridge inverter is a voltage source inverter. So that's clear. Now in McMurray half bridge we have thyristors, and thyristors commutation is done using current. We have to decrease the current of the thyristor. That's why it's current commutated voltage source inverter. Okay, current commutated voltage source inverter. Okay guys, so answer is Calcutta. You can see that it's a memory based question. Especially in machines, power electronics and power system, they will give you less numericals. Okay, numericals will be very less. You will see that simple and direct question will be asked. So you will see that in this session also. So let's come to the next question. Now we have a single phase full converter. For discontinuous load current, extinction angle is beta, which is greater than pi. Each SCR conduct 4. Now tell me each SCR conduct 4 if firing angle is alpha. So for how much angle each SCR will conduct? Tell me the correct answer guys. Tell me everyone, and don't forget to like this session. Don't forget to like this session everyone. Please like it and tell me what is the correct answer. Everyone please reply. What is the correct answer everyone? Do it fast. Let's see. Do it fast. Is it beta minus alpha? Each SCR conduct 4. How much angle it will conduct? Okay, let me show you. You know that this is my supply voltage. Now at this instant T1, T2 start conducting and they will conduct up to beta, and this is alpha, this is pi plus alpha. Okay, at this point, at this instant T3, T4 will start conducting, but the current is going from this point to this point only. It means T1, T2 will conduct from alpha to beta. So the conduction period for any thyristor is beta minus alpha. Okay, so answer is Agra. Answer is Agra. Okay, so this was again a simple question. Let's come to the next question guys. Which of the following statement is related to basic series inverter is incorrect? Which of the following statement related to basic series inverter is incorrect? Okay, so we have basic series inverter, basic series inverter, and which statement is incorrect? That we need to find. Okay, that we need to find. And tell me guys, what is the correct answer? Do it fast. You have 30 seconds. Do it fast. Tell me guys, which option is correct? The incorrect option is rating of commutating components are higher as compared to parallel inverter. So it means it's a memory based question. You should know. But let's find the option which is surely incorrect, and that is the size of the commutating component is okay. So we are not sure about these. I don't remember all these things. Okay. The size of commutating component is higher as compared to parallel inverter. Okay. In first case it's rating, in the second case it's size. If rating is higher, then the size is also higher. Okay, so it means you can get the idea from this. Okay, so A and B cannot be the correct answer. Only one SCR is, yes, that's pretty, okay, that's wrong, because in series inverter 2 SCRs are required. Okay, 2 SCRs are required. That's why only 1 SCR required for the entire operation is not correct. Okay, so answer is Calcutta. Okay, this is the correct answer. It's simple. Okay, we found it like this. Let's come to the next question, guys. The next question on your screen is a step-up chopper is supplied through a chopper means DC-DC converter through a source voltage. This 200 volt is the source voltage. Duty ratio is 0.5. Okay, D is given as 0.5, and it's a step-up converter. So in step-up converter, we know that V0 upon VD is equal to 1 over 1 minus D. Okay, this is the formula that you can apply. And tell me the correct answer, guys. What is the correct answer? Everyone, please reply. What is the correct answer? Yeah, it's 400 volt. Answer is Agra. Simple. Okay, this was simple. Like in 10 seconds you can solve. Okay, let's come to the next. And the next is UPSC ESE result, mains result is out. So you can share your results with us, or whichever faculty you find that from this faculty I got some new concept or some help from that faculty, you can share with that. Okay, let's come to the next question, guys. What is the full form of RBSOA with reference to IGBT? So again, it's a very simple question. Within 10 seconds you can. So it's a reverse bias safe operating area. Okay, answer is Delhi. It's simple. I mean, it's a memory based question. You should know what is the full form of this. Okay, so this type of problem I asked, imagine. Okay, let's come to the next question. Tell me the peak reverse recovery current of a power diode. Now it depends on formula. Okay, peak reverse recovery current, IRR. So if you remember the formula, okay, then you can directly tell. So this is the formula for peak reverse recovery current. Now it depends on the rate of current flow and storage charge. QR is the storage charge. Okay, so it means answer is, tell me what is the correct answer, everyone? Answer is Agra. Okay, answer is Agra. Let's come to the next question, guys. Now tell me, I want reply of this question from your side. A single phase semi converter. We have a single phase semi converter for continuous conduction. Okay, freewheeling diode conduct 4 in a semi converter. For how much time the freewheeling diode will conduct? Tell me, guys. So this is not A, this is actually alpha. Alpha pi, pi plus alpha, pi minus alpha. Tell me which option is correct. Everyone, please reply. Everyone, tell me the correct answer. In a single phase semi converter for continuous conduction, freewheeling diode conducts for how much angle? Tell me. Okay, let me show you. This is the supply voltage. At alpha, you have fired, let's say, T1. Okay, so T1 and one diode is conducting, let's say. Okay, T1, D1. It will conduct only up to pi because freewheeling diode is there. If freewheeling diode is there, conduction cannot be on pi. I mean, this thyristor cannot conduct for beyond pi. Now at this pi instant, freewheeling diode will start conducting up to this pi plus alpha. At this instant, a T2 will get fired. Now for how much time the freewheeling action is there? The freewheeling action is from only in during this interval. It means only for alpha interval. Only for alpha interval, freewheeling action is there. So freewheeling diode will conduct only for alpha interval. Okay, let's come to the next question. A single phase full bridge, a single phase full converter bridge has how many SCR? How many SCR? Tell me, guys. I mean, imagine the level of the questions. Okay, it's a very basic. Okay, so single phase full converter bridge has SCR. How many SCRs it has? Tell me, guys. How many SCR it has? Tell me. Please reply. Yeah, obviously 4 SCRs. Okay, 4 SCR. Answer is Agra. Let's come to the next, guys. We have our mobile app. Okay, so download BYJU'S exam prep mobile app, and there you can give the test and everything you will find there. Okay, so you can go to the Google Play Store and install our mobile app. The link of our app is given in the description also. Okay, so let's come to the next question. Tell me, for which power device this symbol is used? Tell me, guys. What is this symbol? It's a MOSFET. We know that. It's a MOSFET, so it cannot be IGBT. It's a MOSFET. Now, is it a P channel MOSFET or N channel MOSFET? Tell me, guys. Is it a P channel MOSFET or N channel MOSFET? Everyone, please reply whether it is P channel or N channel. It's a P channel MOSFET. Okay. In N channel, the arrow is inward. Okay. In N channel, arrow is inward. That's why it's a P channel MOSFET. Okay. Let's come to the next question. Which of the following is a 3-layer 2-terminal device? 3-layer 2-terminal. Tell me. There must be 3-layer and 2-terminal. 3-layer 2-terminal. Triac does not have 2-terminal. Power diode, yes, power diode has 2-terminal, but does it have 3-layer? Yes. In power diode, actually diode is a PN junction. Okay. But in power diode, we have N plus region also. Okay. In power diode, we have one more region here. So power diode is a 3-layered 2-terminal device. Okay. Just remember this point. Let's come to the next question, guys. In the transfer characteristics of IGBT is a plot. So IGBT. In IGBT, tell me, if you look at the transfer characteristics, it should be this collector current. Okay. Collector current. And this is gate, this is collector, this is emitter. So it should be collector current and gate emitter voltage. Though this question is not pretty clear because transfer characteristics is basically output voltage by input voltage. That you should know. That you should find. Output voltage and input voltage. This is called transfer characteristic. But I think this is not the transfer characteristics. It's a VI characteristics. Okay. So collector current versus gate emitter voltage. Just remember it. Okay. Let's come to the next question, guys. Tell me what is the correct answer for this. A single phase full bridge inverter has DC voltage source of 340 volt. Okay. 230 volt. Okay. So we have now here we have 230 volt. Okay. Now the RMS value of the fundamental component. What will be the RMS value of the fundamental component? So how to calculate the RMS value of the fundamental component? What you can do is you can connect to capacitor and let's say that this is 0 and this is our load. So with respect to ground, so this is externally connected by us. It doesn't matter. I mean, it will not affect any answer. So with respect to ground, what is this voltage, guys? If I draw this voltage will be like this. Okay, it will be like this. Okay, now this peak value is 230 and this is minus 230. Okay, whenever this T1, T2 are connect, the output voltage is 230 and whenever this voltage is connect, output voltage is minus 230. Okay, so this is, even if you don't connect this, no, then also you will get the same wave. Now it's a square wave and you know that the peak value of the fundamental of the square wave is 230 into 4 times by pi. Okay, this is the peak value of the fundamental, but we don't want peak value, we want RMS value. So divide by root 2. Okay, divide by root 2. Now tell me what is the correct value of this. Please calculate its correct value. Okay, please calculate its correct value, and I think this came out to be 207. Answer is Bombay. Answer is Bombay. Okay guys, so this was again a simple question and you can easily solve this problem. Let's come to the next. So guys, we have workshop and you can join this workshop on 23rd of August, which is today at 12 p.m. Obviously it's going on. So anyway, you can register for the next workshop, guys. This workshop is taken by Abhinav Negi sir. Okay, and there is one more scholarship test is also there. That will be on 27th of August. From 9 a.m. to 9 p.m. you can give that test. You can register for this test. Link is given in the description and you can get the scholarship up to 90%. Let's come to the next question, guys. In this question, we have a type C chopper. Now tell me, it's a combination of type C chopper. The name itself suggests C. It come out after A and B. So it's a combination of type A and type B. Simple. And if you remember the diagram, of this, that will be very helpful. Okay, this is our load. Okay, this is our load and This is the diagram for type C chopper. So it's a combination of type A and type B. Okay, this is type A, freewheeling diode, and this switch. This is type A, and this diode and this will be type B chopper. So it's a combination of type A and type B. Okay, let's come to the next. MOSFET. Tell me, guys. MOSFET is a voltage controlled majority carrier, and it's a unipolar voltage controlled majority carrier. So unipolar voltage controlled majority carrier. Answer is Delhi. So this was again a simple question. Within 10 seconds you can solve the problem. Let's come to the next question, guys. The next question is again memory based. Which of the following statement is true or false? The first statement is class A chopper is a step up chopper. No, class A chopper is a step down chopper. Okay, it's not step up. So one is false. Saturable reactor is used in Morgan's chopper. Now this is true, but actually you should go with the Morgan chopper. Please explore it. Okay, I'm not going to teach you about the Morgan chopper, so please explore it. I think answer is Delhi. Okay, one is false, two is true. Okay, please check it. Morgan chopper. Let's come to the next. Now power system has started. So tell me, guys, which fault is indicated in the given diagram? Tell me which fault is indicated here. Tell me, guys, which fault is indicated here? So we have 3 lines, double line to ground fault. I mean, look at the level of the question. Double line to ground fault. Okay, so it's Delhi. Double line to ground fault. It's very simple question. Let's come to the next, guys. Let me tell you, we are running a batch, and for our batch you can join. We have GATE 2024, Vision GATE 2024 and Vision GATE 2024 for EE student, okay, and for EC student as well. So you can cover entire syllabus with us. You can join us, and in this course you'll get the live classes, practice quizzes, recorded lecture, mock test, study material. Okay, so all these things you'll get, so you can enroll for this course. Okay, guys, let's come to the next. The next question on your screen is, in a 3-phase 4-wire balance system, the magnitude of zero sequence current is the current in the neutral wire. So tell me, what should I write here? Which option is correct? We have 3-phase 4-wire balance system. Let's say it's like this. It's like this, guys. If zero sequence current is coming here, let's say it's IA0. We know that this is IB0, and IB0 is same as IA0, and this is IC0. And in the neutral, you have 3 times of IA0 because these are equal and they are in same phase. So if you combine, the neutral current is 3 times of zero sequence current. 3 times of this zero sequence current. Neutral current. But from the neutral current, I need to find the zero sequence current. So what I need to do is, I need to take 1/3 of that. From the neutral current, if you want to calculate the zero sequence current, then you have to take 1/3 of that. Okay. So in this question, it is asked about the zero sequence current is 1/3 of the neutral wire. So answer is Agra. Okay. I hope it is clear. Answer is Agra. Tell me, guys, can I proceed? Let's come to the next question. Tell me, I think in this question, per unit value, here it should be division. Okay, it should not be plus. So tell me which option is correct. Per unit value of any quantity is actual value divided by base value, actual value plus base value, actual value minus base value, actual value into base value. Which option is correct, everyone? Tell me. So per unit value is actual value divided by base value. Okay, this is the formula for per unit value. Actual value divided by base value. Let's come to the next question. The next question on your screen is, a 2-wire feeder supplies a constant load with a sending end voltage of 220 volt. Okay, so sending end voltage is a 220 volt. Okay, now calculate the saving in copper if voltage is doubled with power transmitting remains the same. It means the power is same but voltage get doubled. If voltage get doubled, then current has to be halved. It means current has to be halved. And how to calculate current? Current is V upon R. R is rho L by A. Rho L by A. It means you can say that if current get halved, the cross section area of the wire get halved. Cross section area of the wire get halved. And if cross section area of the wire get halved, then the volume of the wire volume of material, volume of copper or maybe anything, aluminium, that get halved. Okay, because we know that volume is equal to cross section area into length. So you can say that if I increase the voltage, if I double the voltage, current has to be halved because power is same. If current is halved, then the area, cross section area of the wire will get halved. If cross section area of the wire get halved, then the volume of the copper material will also get halved. So how much saving we have? 50%. Okay, 50% saving. That's why power is transmitted at high voltage. Okay, at high voltage, because it will save your material. Let's come to the next question. Which of the following is an example of symmetrical fault? Tell me, guys. Which of the following is an example of symmetrical fault? Tell me which option is correct. Symmetrical fault. Which of the following example? Which of the following is an example of symmetrical fault? Symmetrical fault, line to line to line fault. Okay, so it's a symmetrical fault. Symmetry is there, na? Every phase you have the fault. We call it symmetrical fault. These are unsymmetrical because only two lines are under fault. Only one line is under fault. Only two lines are under fault. So symmetrical means on all the three lines it's same. So that's why answer is Agra. Let's come to the next question, guys. The next question is, in a DC 2 wire feeder, the drop per feeder conductor is 2%. So it's very simple. It's a voltage drop. Okay, it's a voltage drop, or you can say power drop. Okay, because V into I. Let's take current same in both the wire. So you can say that the power drop is 2% in each conductor. So there are two conductors actually. So 4% power drop you can say. So efficiency is almost 96%. Okay. So transmission efficiency of the feeder is 96%. It's very simple. Okay. Let's come to the next question, guys. In a transmission system, the cost of the conductor is proportional to. Tell me which option is correct. Tell me everyone which option is correct. Cost of the conductor is proportional to. Which option is correct? Everyone. Cost of the conductor is proportional to. Tell me what is the correct answer. Cost of the conductor is proportional to area. Yes, area. Because it cannot be proportional to color or smoothness of the surface. Area, because you know that the area will decide the volume. Volume of the material is equal to area into length. Area into length. Okay. Now the area, if you look at the area, that will decide the volume, and volume will decide the material. Okay, and the cost obviously. Okay, so you can say that the area is the cost is proportional to area or volume of the material. Volume is not given, so area I have to take. Let's come to the next question, guys. The next question on your screen is formula based. If a percentage reactance per unit reactance is given to us, up to the fault per unit reactance is 0.20 and the base kVA is given as 10,000. This is the base kVA. Now I need short circuit kVA or fault MVA. Fault kVA. What is fault kVA, guys? You can directly apply the formula. It's base kVA divided by the per unit impedance up to the fault. Okay, you can do this, and I think answer is 50,000. Answer is Bombay. Okay, it's very simple, guys. It's very simple. Let's come to the next question. And the next question is, now look at the level of the question. But before going into that, let me call Naveen sir, okay, so that I can ask him whether he is ready or not. Till then you can solve this question, guys. Because machine and instrumentation will be covered by Naveen Golapalli sir. So I have only two questions, sir. Okay, sir. Okay. So Naveen sir will continue from the last question, but let's first cover this question. So we have 230-kilometer line, and it is called, tell me guys, what is this? Is it a short transmission, long, or ground, or medium? We know that at 50 hertz, actually this question is not correct, because the line length will decide whether it is short or medium or long if frequency is provided to you. Because if the frequency is megahertz, let's say 50 megahertz or 100 megahertz or 1000 megahertz, if the frequency is that much large, even 1 meter line will act like a long transmission line. Okay, so it means this word is relative. I mean, it has to be given the frequency. But since we are, I mean, if nothing is mentioned and we are from electrical engineering, so by default we have to take 50 hertz. So at 50 hertz, if the line length is less than 100 kilometer, we call it short. Okay. If the line length is greater than 100 kilometer, is greater than 100 kilometer, if line length is greater than 100 kilometer and less than 250 kilometer, we call it medium transmission line. And if the line length is greater than 250, we call it long transmission line. So tell me guys, this is under long transmission line. Okay, at 50 hertz, this is under long transmission line. So you have to be very careful. But actually it should be related to the frequency. At 50 hertz it happens. At 60 hertz, things will be different. Up to 90 kilometer we take short. Okay, up to 90 kilometer we take short. Because I told you, no, frequency, if you increase the frequency, then this reference value of the, I mean the length at which you are taking as medium or short, or that will decrease. You can see that at 100 megahertz, even 1 meter length, 1 meter long length is treated as long transmission line. So it all depends on the frequency. Anyway, so at 50 hertz, this is correct. Let's come to the next question, guys. Tell me, a conductor that connects the distribution substation to the area where power is to be distributed is known as, tell me which option is correct. Everyone, please reply. Which option is correct? Everyone, please reply. Tell me the correct answer. A conductor that connects the distribution substation to the area where power is to be distributed is known as. Tell me which option is correct. It's a very simple question. It's a memory based question or knowledge based question. It's called feeder. Okay. It's called feeder. Answer is Calcutta. It's feeder. Okay. I hope it is clear, everyone. So now I think Naveen sir is ready. So let me ask Naveen sir again whether he is ready or not. So there will be a glitch of like 5-10 seconds, guys. Okay. And then Naveen sir will continue for machines and instrumentation. Okay guys, so don't forget to join my Telegram. This is the link of Telegram and given in the description also. So you can join it and you will get these things on the Telegram. So I will be more active on the Telegram now. So you can join this link and don't forget to subscribe our channel and like this session. This will be the Guru Dakshina. Okay. So you have to give the Guru Dakshina, guys. So let me ask Naveen sir whether he is ready or not. Okay guys, so you have seen that the level of the questions is very simple. Okay, now if you compare the level, I mean, look at the level of this question. It's very simple, very simple question. It's almost a JE level question or less than JE level. Okay, even JE level has JE in the JE exam, the questions are of good level. Okay, so the level is very simple. So let me ask to Naveen sir whether he is ready or not. Hello. Sir, mute पे नहीं हूँ. So guys, now Naveen sir will continue and there will be a glitch of 4-5 seconds or 10 seconds. So you have to be patient. Please continue for machine and instrumentation with Naveen sir. Thank you, and I hope you enjoyed. Take care.
Hi, hello guys. Good afternoon, one and all. Welcome to the session. Can you confirm about audio and video? Hello guys. We are going to discuss about HPCL last year question paper, 2022 question paper. Please do confirm about audio and video so that I can move on to the session. All right. Right. In this session, I'm going to cover some questions on machines and measurements. So I'll start up with machines questions and then we'll move on to measurements questions. Okay. Right. There is a small introduction about myself. Those who do not know about myself Naveen Gollapalli. I have around 11 plus years of experience in teaching. Most of the times I'll be teaching electric circuits, machines, measurements and power systems. And I did my masters in electrical power system from JNTU Hyderabad. Okay, right. So if you have any doubts and if you want any guidance, you can reach me on this Telegram channel. Okay, or else you can reach me on this mail ID also. If whenever you get a doubt or if you want any suggestion, you can reach me on this mail ID also. All right. So let's start with the question. I have a question on DC machine. The question he has given it as, identify whether the given statements with reference to DC machines are true or false. Whatever the given statement is there, that statement is true or false, he is asking. Okay. So look at the statement. The Swinburne's test cannot be performed on the DC series motor. First statement. And the second statement he has given about the Swinburne's test is non-loading test. Swinburne's test is a non-loading test. That is what he is saying. Okay. I think if you have done an experiment on the shunt motor or otherwise compound motor, that motor will be having a shaft, and that on the shaft you will be having generally brake drum will be there. For every motor, generally in the laboratory we will be having a brake drum. On this we will be placing the belt load. On this we will be placing one belt load. But there is one motor which doesn't have this brake drum, and this you cannot have a brake drum at all. So simply there will be a shaft, extended shaft outside. You don't have even brake drum also. That means if you do not have a brake drum, there is no load also. There is no load due to brake also, due to drum also. So this kind of motors will be used to perform the Swinburne's test. So Swinburne's test is basically no load test. So due to that no load test, you can find out no load losses. Okay. You can generally, maybe it is a generator or motor, you can operate it as a motor and calculate the losses. You can find out the efficiency of the generator or otherwise motor by finding out the no load losses. So Swinburne's test is actually a no load test which is performed on DC series motor. Which cannot be performed. He has given it as which cannot be performed on DC series motor. Why? If it is series motor, if the series motor running on no load, the current drawn by the series motor is going to be very generally under no load the current is going to be very less. If the current is very less, flux is very less, and the speed tends to be infinity. Okay, so we cannot conduct the Swinburne's test on series motor, but you can conduct on shunt motor and compound motor. Shunt motor and compound motor, but not on series motor. Therefore, the first statement is true. The first statement is true. You cannot conduct on series motor. What is the second statement? Swinburne's test is a non-loading test. We are not at all placing any load. Yes, it is a non-loading test. It is an indirect method of testing. So option statement 1 and statement 2, both are true. Both are true. See, 1 is true and 2 is also true. Very good. Voice is very low. Is it clear now? Ashok? Ishwar, it is C. Very good. Ashok, C. Very good. A is not correct. A is not correct. Both are true statements. Is it okay now, voice? Right. Let us move on to the next question. He has given a question on induction machine. A 746 kilowatts 3-phase 16 pole induction motor has a rotor impedance of 0.02 and J.015 ohms at standstill. Okay. Full load torque is obtained at 360 rpm. Full load torque is obtained at 360 rpm. He is asking calculate the speed at which maximum torque occurs. He is asking the speed will be generally NR equals to NS of 1 minus S. So he is asking the rotor speed at which maximum torque occurs. So if he is asking maximum torque speed, then you need to substitute maximum slip corresponding to maximum torque. Okay. How do you calculate NS? NS will be 120 into 50 divided by 16 poles. Okay. For 8 poles it will be 750. For 16 poles it will be 325. So 375 probably. For 8 pole it will be 750. Now for 16 poles it will be 350. 350 plus 25, 375. Now 1 minus ESM. Slip corresponding to maximum torque. How do you calculate slip corresponding to maximum torque? Rotor resistance divided by rotor reactance. Now, rotor resistance is 0.02, rotor reactance is 0.15. So it will be 2 by 15. Okay. So you substitute this value, so you will get this value. Your rotor speed corresponding to maximum torque must be less than 375 rpm. Must be less than 375 rpm. So you can overrule, you can eliminate 375 rpm. Definitely the answer will not be more than 375 and equal to 375. Can you tell me what could be the answer? It should be less than 375 rpm. So 1 minus 2 by 15. 1 minus 2 by 15 times 375. I'm getting around 325. Very good, Ishwar. 325. If you have any doubt, you can ask me. So this is a session. There is a session where just to tell you about the model question paper about HPCL. Okay, HPCL question paper, just to know. This is a very basic question they have asked. Okay, if you have taken a coaching from BYJU'S exam prep platform, I think for GATE or ESE, I don't think it is going to be a tough deal for you cracking the HPCL examination. I'm damn sure, because very fundamental questions and basic questions they have asked. Chalo. Let's look at this question. Which of the following methods of speed control cannot be used for squirrel cage induction motor? Squirrel cage induction motor, you can have stator and of course rotor. The squirrel cage rotor will be there. Squirrel cage rotor is going to be short circuited rotor, no? So you cannot add rotor resistance, you cannot inject the EMF. So rotor resistance control technique, injected EMF injection methods are not allowed. So which is allowed? Whatever the control technique you want to do, you can do only from the stator side, but not on the rotor side. So with you do not have a slip rings at all, so slip power recovery is not at all possible. Stator voltage control is possible. This is possible. Stator frequency control also possible. Stator variable voltage and variable frequency control technique. These three are possible. These three are possible, and this is not possible because we do not have slip rings at all. So how can you recover the power of the rotor from the slip rings? 61 is A. Very good, Ishwar. So let's move on to the next question. Here the question is given about if the flux produced by one coil doesn't link the other coil. The flux produced by one coil doesn't link the other coil. Then value of the coefficient of coupling. So I have a flux whenever it is carrying a conductor. Now it is producing some amount of flux. Okay, it is producing some amount of flux. Now it is not linking with other flux. So what is the coefficient of coupling? Generally coefficient of coupling will be, if it is 511, so generally 511 if it is coil 1 and coil 2, now the flux produced by coil 1 is going to be taken as 5-1. Out of this 5-1, some part of the flux links with N1 only, some part of the flux links with N2. So this is going to link with N2 and this is going to link with N1. Now coefficient of coupling will be defined as like this. Out of total flux, how much amount of flux is linking with other coil? He is saying that there is no flux is linking with other coil. 5 and 2 is absolutely 0. Now what is the coefficient of coupling? It will be 0 or not? It will be 0 or not? Very good, Ishwar. Ashok, come on, respond. Others also respond. Look at this question. In DC machine, the hysteresis losses are covered under the category of hysteresis losses, eddy current losses are means what? The summation of these two will be iron losses. No, iron losses are constant losses or no load losses, we generally say. No load losses means in the rotating machine, no load losses means iron losses plus mechanical losses will be no load losses. Hysteresis loss comes under, will it comes under brush losses? No. Will it comes under electrical losses? Will it comes under electrical losses or magnetic losses? Hysteresis loss, eddy current losses which are going to take place in the steel or iron part. So it's not in the conductor. Okay, it is also not mechanical losses. So I can say it as iron losses. Okay. These kind of very small questions or concept oriented questions they have asked. So maybe the questions are so simple, but the time duration also matters. So you should be very much quick and perfect. Okay. So coming to this one, there is announcement. Of course, UPSC Engineering Service Examination results are out. If you are planning for interview guidance, then BYJU'S exam prep platform is going to give you the guidance. Definitely, it will help you to crack the interview. So try to take the use of this guidance, okay, given by the expert panel. Right. Now, next question. Let us have a look at next question. With reference to the skewing of this cage rotor of an induction motor, identify whether the given statements are true or false. Skewing. Why do we go for skewing? Generally, skewing means inclined slots. Inclined slots. Like this. Okay. Why do we do this one? Generally, if the slots are in parallel to the stator, if the rotor slots are in parallel to the stator slots, then there will be chance of locking at the time of starting. So to avoid the locking, then we go for skewing. You can do it on stator also. Why only on rotor? You can do it on stator also. Any one is preferred, but generally we do it on rotor because rotor size is of very small compared to stator size. Stator size is of very large, and we will be accommodating more number of conductors. So it is a little bit tough to go for skewing, and not tough, but the thing is it's better to go for skewing on the rotor. Okay. Moreover on the rotor, we can place bars, rotor bars. So it's very easy. Skewed rotor slots, skewing or inclined slots, designing inclined slots on the rotor is very easy, and placing the simple one bar conductor, it is very easy. Okay. Right. So why do we prefer this skewing? To avoid locking. Right. The first statement is due to skewing, noise is reduced during operation. And the second one is locking tendency of the rotor is reduced. This is for sure, damn sure this is going to be true. What about noise? Definitely skewing results in it can eliminate the locking tendency, and skewing, because of skewing you can eliminate the slot harmonics also. You can eliminate slot harmonics. So because of absence of slot harmonics, definitely smooth operation is possible. So you can choose skewing. Definitely prefers a smooth operation. It will not result in noisy operation. It will results in smooth operation. You will not get noisy operation, you will get smooth operation only. Because wherever there is an elimination of harmonics, definitely it's a smooth operation. It won't be a noisy operation, right? So the I can say statement 1 also going to be true. So I can say 1 and 2 both are true. Option B is the correct answer. Okay. Next question, if you see, in a single phase transformer, the ratio of transformation is, means K is asking, K is given 2. Transformation ratio is 2. The secondary resistance is 0.24. Find the resistance of secondary in terms of primary. So whenever you have like this, I have a secondary resistance R2, and this is my primary winding and secondary winding N1 and N2. Now whenever you want to transfer on primary side R2 dash, it will be R2 by K square. So find the resistance of secondary in terms of primary. In terms of primary means transfer onto the primary side and calculate. So if you transfer, it will be R2 by K square. R2 is what? 0.24. K square is what? K is what? 2. 2 square will be 4. So 0.24 by 4. So it will be 0.06 or not? 4 6 are 24. 0.06. Answer is C, not A. Probably. Ishwar, can you check once again? 0.024 divided by 4, na? Right. In case of, just a minute. In case of slip ring induction motor, external resistors are connected in the rotor circuit to increase or decrease the starting torque, and increase or decrease the starting current. What is going to happen when you are going to connect an external resistance? When you are going to connect an external resistance, okay, to the rotor, an external resistance is getting added. If extra resistance is getting added, means definitely current will reduce, na? Definitely current will reduce. Starting current will be inversely proportional to impedance. Here resistance part is increasing, R2, external resistance part is increasing. So if resistance part increases, current will definitely reduce. So decrease, second option should be decrease, not increase. Option B and option C can be eliminated. What about torque? The starting torque, especially at the time of torque, the starting torque, if you see the relation, if you remember the equation, S into E2 square into R2 divided by R2 square plus S times X2 whole square. At the time of starting, slip is 1. So here X2 square is dominating than the rotor resistance. So I can neglect the rotor resistance. Now how will be the formula? Starting torque is proportional to E2 square into R2 by X2 square. E2 square into R2 by X2 square. So starting torque is directly proportional to R2. If rotor resistance is connected, then definitely starting torque also increases. So torque increases and current decreases. Option A could be the correct answer. Very good, Ishwar. Others also please do respond, guys. Determine the regulation of transformer in which ohmic loss is 1% of the output. Ohmic loss is 1% of the output. That means he is giving directly percentage resistance. And the reactance drop is percentage reactance, or percentage reactance drop is 5% of the 5% of the output. So 5% of the output, that he has to mention. Now the voltage regulation when power factor is unity. The voltage regulation when the power factor is unity. If you remember the percentage regulation formula, X into percentage R into cos phi 2 plus or minus percentage reactance into sin phi 2. Okay, power factor is 1, so sin component is 0. So any value of percentage reactance doesn't matter. So percentage resistance is how much? 1%. What is the load he has given? Did he mention anything? He did not mention anything about the load. So simply percentage regulation will be equals to, you can mention it as percentage X times 1%. 1% you will get. So you should assume X value as 1, then only full load. If you assume full load, then you will get full load regulation. Is it clear for everyone? Percentage regulation will be equal to percentage resistance when the power factor is unity. Okay, so you see there is a actually there's a good thing about the BYJU'S exam prep platform app. You can have a poll based classes also will be there on the app, which is not possible in YouTube, right? In YouTube I cannot project the polls here. I cannot project the polls, but when it comes to app, BYJU'S exam prep app, I can ask you, I can post you the question, and I can ask you the I can ask you to select the correct options A, B, C, D. Okay, so it's like a real-time examination field. To get the real-time examination field, we are going to conduct the poll-based questions also. So try to take the use of that BYJU'S exam prep free classes. Okay, right. And you can see the scoreboard also, those who have scored according to the right questions, the scoreboard, and you can see you can check your place also. This time I'm more of promotion oriented. I'm promoting BYJU'S exam prep lot now. Right. Ashok, you're so silent. Tell me what happened. Ishwar, only Ishwar is giving the answer. Others also please do respond. A synchronous generator is rated at 40 MVA, 10 kilovolts and 50 Hz. The base impedance of the generator is, you can do by using per unit, what I can say, per unit reactance or per unit impedance formula. Z per unit is equals to Z ohm into MVA by KV square. Okay. So what he's asking also, he's just asking only base impedance, right? He's just asking base impedance. Base impedance means base voltage divided by base current. What is a base voltage? This is a base voltage, 10 kV. What is a base current? What is a base current? How do you get base current? So base voltage into base current will be give you the base power. So base current can be taken as SB divided by VB. That is 40 MVA divided by 10 kV. So this is M na, so 10 to the power of 6. 10 kV, 10 to the power of 3. So this comes out as 4 and 4 into 10 to the power of 3. 4 kilo amperes. Now tell me the Z base. 2.5 na? Kilo gets cancelled. 10/4 कितना आएगा? 2.5 ohm आना चाहिए. Very good, Ishwar. I think, Ishwar, you have gone through the previous question paper of HPCL. It seems you are answering all the questions. Or I think you might have a good command and the basics. Very good, Ishwar. How many parallel circuits are formed in a 4-point starter? 4-point starter, how many parallel circuits are formed? So generally, if you look at shunt motor or otherwise compound motor, generally we will prefer the 4-point starter on the shunt motor, otherwise compound motor. So if you look at shunt motor, armature path will be there, field path will be there, right? So definitely there are two parallel paths, right? Definitely there are two parallel paths. Okay. Now I need to place the starter. Starter is nothing but what? Starter is nothing but what? Starter is nothing but what? Large variable large variable external resistance. You need to connect from outside. Large variable external resistance has to be connected in series with the armature. Why? We need to minimize the starting current which is entering into the armature. So connect a large variable starting resistance. Large variable starting resistance on case. Okay. So you can put this on this armature point. Generally you can put it on position 1, position 2, position 3, like that. You can place, generally we will place in the large value at the initial point of time, and then we'll minimize the armature resistance towards the minimum value. So that's how it is going to be. Okay, right. For field, it will be connected to and connected through an arc. So you'll be having a starter stud. So this starter stud will be initially connected at large resistance like this. Now you move on to position 1, position 2, position 3, position 4, like this. When you move on to position 4, the resistance connected is completely eliminated, na? The external resistance. Now the current flows like this. The current flows like this through the armature. Yes or no? This is our supply. So there are two parallel paths. One is armature parallel path. There is another one is field parallel path. But the drawback with the 4-point starter is, with the 3-point starter is, you cannot go for flux control method. That's the reason why we will go for another one, that is a resistor. You can take up in a neutral manner. So this is also connected here. But here you will be placing the no volt coil in series with the neutral path, but not in series with the field path. So this is an extra path you are going to get. So current will flow through this path, current will flow through the path, field winding path, current will flow through the armature winding path. So there are totally 3 paths. Okay, 3 paths. In 3-point starter, you will be having field winding path and armature winding path. 2 parallel paths. In 4-point starter, you will be having 3 paths: armature, field, and the neutral path. It's a none path to say exactly. Don't say it is neutral, because as it is a DC supply, you cannot say it as a neutral. That's better not to say neutral. It's a none path. No, what I can say, it's nothing, none path. Right. Is it clear for everyone? No, not 4. It's 3. Parallel paths are only 3. Armature path, field path, and neutral other, none path. So don't expect this supply path as one more path, okay? He did not ask about points. The points are 4 points. Points are 4 points. Line, armature, field, and the neutral. 4 points. Parallel paths are 3 only. Yes or no? The current is, this is the current delivered by the supply. Now this current has to divide through this field winding, has to divide through armature, has to divide through this neutral or none path. The current is dividing into 3 paths only, so 3 parallel paths. You cannot say 4. Okay. Look at this question. Which of the following is not a valid voltage level for primary distribution? Generally, the distribution is from 11 kV or less than 33 kV. Distribution level less than 33 kV. Above 33 kV is going to be transmission level. So, out of all these, the odd one is 66 kV. Generally, this 66 kV is transmission voltage level, na? Okay. So you can take up the first 3 levels are going to be distribution voltage levels. 66 is not distribution level voltage. Huh? He is asking which is not distribution voltage level. 66 is not distribution voltage level. It's a transmission voltage level. Okay. Right. In the field flux control method of DC motor speed control, dash power and dash torque is obtained for speeds above base speed. If you remember the speed control, generally you can take up this as rated speed. Okay. So there are 2 techniques, popularly 2 techniques: applied voltage control technique and flux control technique. So in applied voltage control technique, you will get less than the base rated or less than the rated speed. Applied voltage control technique is a constant torque and variable power. Constant torque and variable power method. Applied voltage control technique is a constant torque and variable power method. But when it comes to flux control method, variable torque and constant power. So this is flux control method. So I can write here constant power and variable torque. Okay. D could be the possible right answer. All right. Look at this question. Which of the following statements about DC series motor is incorrect? Incorrect statement is asking. It is a variable flux machine. It's a variable flux machine. Yes. Shunt motor is a constant flux machine. Series motor is not a constant flux machine, because as long as the load changes, current changes. If the current changes, series field flux also changes, right? Because flux is directly proportional to series field current and is directly proportional to load current or armature current. So as the load changes, armature current, load current, series field current, flux also gets changes. This is true. It is not correct. It is true statement or correct statement. Its speed versus armature current characteristics is straight line. Is it so? N is it directly proportional to IA or IA square? IA or IA square? N is directly proportional to IA square or IA? Torque is directly proportional to IA square. No. Torque is directly proportional to IA square. Speed versus armature current characteristics is asking. The speed versus armature current characteristics, if you draw, it look like rectangular hyperbola. It's not a straight conductor. It's not a straight line. For shunt motor, it's a straight line. So this is incorrect. Rest of this C and D are obviously correct only. Series motor should never run on no load. It must never run unloaded. Unloaded means no load. You cannot run on no load. Its speed is inversely proportional to the load current. Yes, speed is inversely proportional to load current. Not directly proportional to the load current. Okay. Is it clear for everyone? Guys, there is a scholarship test. Those who are planning for ESE and GATE examination, there is a scholarship test which is going to be held on 23rd August. Right. Oh, sorry. Scholarship test is on 27th August. There is a workshop on 23rd August. So this workshop will be taken by Abhinav sir, and he'll be giving you some tips to crack the GATE examination. Okay, so try to take the use of this one, and this will definitely help you in order to crack the GATE examination. And the timings is on 12 p.m. Okay, so if you are confident about cracking the GATE examination, I'm damn sure definitely you'll get a confidence after attending this workshop. Try to attend the scholarship test so that you'll get some discount or concession on the actual fees, right? So you can write the scholarship test from 9 a.m. to 9 p.m. anytime on 27th August. Right. There is one more question. A single phase transformer has 400 primary and 1000 secondary turns. If the primary is connected to a 500 volts 50 Hz supply, find the secondary voltage. We know it's magnetomotive force balance N2I2 is equals to N1I1. Na? I know N1, I know N2. What is asking? He's asking find the secondary voltage. You can also get this one as E2I2 is equals to E1I1, right? Alright. So what I can replace, wherever E2 is there, I can replace N2. Wherever E2 is there, I can replace with N2. Wherever E1 is there, I can replace with N1. Okay. So how can I write now? E2 by N2. E2 by anything. You can write this one also. E2 by N2 is equals to E1 by N1. EMF per turn on the primary side, EMF per turn on the secondary side will be same from the EMF equation. He has given number of turns. He is asking secondary voltage. So secondary voltage E2 is equals to E1 by N1 into N2. E1 is how much? E1 is how much? 500 divided by N1 is 400 into N2 is how much? 1000. So tell me E2. How much is E2? 2 शून्य काट कर लो 4 गुना 2 8 हो जाएगा 5 बचेगा 2 बचेगा हाँ राइट 250 ना 250 गुना 5 क्या हो जाएगा 1000 हो जाएगा ज्यादा है क्या टू zeros cancel out. So 2.5 into 5, it's 1250. Okay, very good, Ishwar. Gone case. In a DC machine, in DC machines, the method of achieving good commutation with the help of interpoles. Interpoles are also called as commutating poles, COM poles. So with this one, an extra flux is coming onto the armature winding, and therefore armature is going to induce an EMF against to the delayed commutation. So that EMF is going to compensate the delayed commutation. So that's why it is called as voltage commutation. Why voltage commutation? This voltage is induced due to interpole flux only. Okay, that's why it is called as voltage commutation. Okay. Right. So that's about the machines questions. If you look at machines question, all are very, very simple questions only. Concept oriented questions and very basic questions. Okay. If you have any doubts so far, you can ask me. All right. Please try to comment in the comment box. पूछ लो यार कुछ तो पूछ लो तो मैं कोशिश करता हूँ आंसर करने को कोशिश करता हूँ लक्ष्मी प्रसाद इंस्ट्रूमेंटेशन इंजीनियरिंग का 2001-2022 प्रीवियस ईयर क्वेश्चन कर दीजिए 2021-2022 अच्छा ओके राइट I'll definitely forward it to the backend team. They'll plan it, will definitely take up. Okay, Prasad, accepted. 2021 इंस्ट्रूमेंटेशन चाहिए ना आपको, राइट। बात ये है ना, इंस्ट्रूमेंटेशन, ठीक है, राइट, we'll see that. I'll forward it. Shashikant, okay, I'll forward to the backend team. Right. So from here onwards, we'll take up measurements questions. Let us look at measurement questions. What's the time? 1:30. Calculate the sensitivity of 0 to 1 milliampere meter. Is asking sensitivity. Sensitivity is generally ohm per volt, na? So this ohm per volt can be taken as volt per resistance. Ohm per volt, volt per resistance. Just bring this resistance ohmic value to the down. You can write this as V by R, 1 by V by R. So sensitivity is inversely proportional to current. So I have a current, full scale current. So can you substitute full scale current 1 milliampere? If milli goes up, 10 to the power of 3. So sensitivity is going to be 1 kilo ohm per volt. 1 kilo ohm per volt. A is the correct answer. So BYJU'S exam prep is launching some courses for 2024 aspirants, GATE 2024 aspirants, first ECE aspirants and EE aspirants as well. This vision GATE 2024, you can have live classes access, recorded classes access, and you can have study materials, mock tests and practice questions, quizzes, many more to come. Okay. Look at this one. Which of the following is not an application of DC potentiometer? DC potentiometer. Potentiometer, DC supply. So definitely potentiometer is generally measures the voltage, small voltage range and small current range. So if you are able to measure current and voltage, you can also measure power. So measurement of current can be done, measurement of resistance can be done, measurement of power also can be done. Now which is not possible? Measurement of self-inductance is not possible generally. That slide where we'll be having very resistance nature, very huge resistance nature. Moreover, DC supply you are giving, so you cannot find self-inductance. Coil inductance cannot be calculated. Okay. So the better answer is what? The better answer is what? Which is not possible? Inductance. Okay. Come on, Ishwar, Ashok and others, please do respond. Look at this question. A voltmeter used for a measurement of line voltage of 230 volts indicates 232 volts. Indicates 232 volts. That means what? This is a measured value and this is a true value we have applied. Find the static error. Generally static error will be measured value minus true value. Measured value कितना दिया? 232. ट्रू वैल्यू कितना? 230. क्या आएगा आपको? 2 वोल्ट आएगा. C is the answer. Look at this question. A PMMC can be used as DC voltmeter without a series resistance in the range. Without a series resistance in the range. So I have a DC voltmeter, PMMC voltmeter. This is meter resistance and I have a pointer like this. So if you want to increase the range of the meter, add resistance in series, a large value of resistance. If you don't want to increase the range, that's fine. That's fine, na? So some part of the current will flow in the range of milliamperes or microamperes. Now that current into resistance will give you millivolts or microvolts. Millivolts or microvolts range voltage. So will it be 1000 milli means milli kilo gets cancelled, so it will be 0 to 1 volt range. Generally we don't measure in this one. So 0 to 0.1 volts range. It is also okay, fine. 0.1 it's fine. 0.01. 0.001. So prefer always a lesser value. Do not prefer a larger value. Prefer always a lesser value. It doesn't mean that you cannot measure up to 0.1 volt. you can measure 0.1 volt also. 100 millivolts is not a big deal. Okay. PMMC will measure the voltage in the range of millivolts and microvolts. It's a small value generally. These three also possible answers. Best possible is least value. Select the least value. Okay. Look at this one. Which of the following types of instrument is used for only for AC measurement? PMMC, you can go for DC. Hot wire, you can go for DC as well as AC. He is asking only AC. Thermocouple also you can go for DC as well as AC. So the only thing is induction type. Induction or mutual induction is possible only in AC supply. Induction is possible. Mutual induction is possible or induction is possible only in AC supply. Induction type meter. AC measurement. Only for AC measurement. Look at this question. A slide wire is used for measurement of current in a circuit. The voltage across a standard resistance is 1 ohm. Is balanced at 75 centimeters. Find the magnitude of the current if the standard cell having an EMF of 2 volts and is balanced at 50 centimeters. I think question data he has given a different manner. Okay. So if you look at potentiometer arrangement, the potentiometer arrangement will be like this. Adjustable rheostat, working battery, and here it is like this. And you can have the slide wire here. So the slide wire resistance, he has given it as the slide wire resistance, he has given it as 1 ohm. Total length he has to give actually. 75 centimeters. Find the magnitude of the current if the standard cell is having an EMF of 2 volts. Okay, let us take up EMF, standard cell EMF of 2 volts. Now I have a galvanometer. Magnitude of current, find the magnitude of current if the standard cell is having an EMF of 2 volts is balanced at 50 centimeters. So this galvanometer, when it is placed at 50 centimeters, the voltage across 50 centimeters is equal to what? The voltage across 50 centimeters is equal to what? Standard voltage. Why? Galvanometer shows 0 reading, null reading. That's what standardization or balancing condition. Okay. Initial balance is obtained at 1 ohm 75 centimeters. Okay. Now, let us take up no issues, but we want current. Okay. So the voltage across 50 centimeters is how much? 2 volts. Okay. So if you know the resistance of the 50 centimeters, then you can calculate current, na? Because voltage across this 50 centimeters is 2 volts. Now calculate the resistance of 50 centimeters. Now he has given that the voltage across the standard resistance is 1 ohm is balanced at 75 centimeters. So for 75 centimeters the resistance is 1 ohm, no? For 75 centimeters the resistance is 1 ohm. 75 centimeters the resistance is 1 ohm. Now 50 centimeters how much? Definitely less than 1 ohm, right? Now 50 divided by 75 into 1, you will get definitely 50 by 75. You are going to get it as 0.66 or otherwise 0.67 centimeters. Okay. Oh, sorry, 0.67 ohms. Now for 0.67 ohms, that means what? What I can say, for 50 centimeters I am going to get 0.67 ohms of resistance. I know the voltage, I know the resistance. Can't you calculate the current now? Now the current is going to be 2 volt divided by 0.67. 2 divided by 0.67. I am getting 3 amperes. Okay. Look at this question. With the help of 4.5 digit voltmeter, the largest possible reading is 4.5 digit. 4 digit means 1, 2, 3 and 4. These are 4 full digits. And there is half digit. Half digit is to increase the range of the DVM. Okay. If these are 4 full digits, 4 full digits are there. So I can 4 full digit, final value is what? Maximum value is what? 9. Half digit is of maximum value is 1. So 19,999. The largest possible reading is not going to be 4,000. It's not 4 or 9. It's going to be 19,999. A 1 milliampere ammeter has a resistance of 100 ohm. Calculate the shunt resistance required to convert into 1 ampere ammeter. So basic range is what? 1 milliampere range, and he wants to convert into 1 ampere range. So to convert into 1 ampere range, you need to use a shunt. So RSH is equals to Rm by M minus 1. What is M? Extended current to the meter current. Meter current I know 1 milliampere. Extended current is 1 ampere. So this comes out as 1 kilo. 1000. 1000 minus 1. It's 999. What is the meter resistance? 100. If it is 100 by 1000, 1 by 10, 0.1 you will get. Okay. So the RSH must be less than 0.1. It is not 0.1. It is not 1.1. It is not 0.11011. It is not 1000 at all, like this. Okay. Shunt resistance must be less than 0.1. I'm sorry. I think this B is going to satisfy. Even D also not going to satisfy, because it is 100 divided by 999. If it is 1000, you will get 0.1. If it is 1000, you will get 0.1. Okay, right. If it is less than 1000, you will get greater than 0.1. RSH should be greater than 0.1. So 0.01 could not be the answer. So greater than 0.1 is 0.1001. This could be the answer. B is the answer. Okay. Look at this one. In a potentiometer circuit, a cell of 1.5 volts EMF gives a balance point at 30 centimeters. So voltage across 30 centimeters is what? Voltage across 30 centimeters is nothing but 1.5 volts. If another cell is 2.5 volts, EMF replaces the first cell, and then what length of wire will have a balance? So you are getting a balance at 30 centimeter, 1.5. Voltage across 30 centimeter is 1.5. Okay. Now if you are replacing the cell with 2.5 volts, when will you get the balance? Voltage is directly proportional to resistance. Voltage is directly proportional to length of the wire. Why? Because V is equal to IR. Current, let us make it standardization. Current, make it constant. Voltage is directly proportional to resistance. Resistance is proportional to length. So you can take up voltage is directly proportional to length. So for 2.5 volts, how much length is possible? 2.5 divided by 1.5 into 30 centimeters you will get. Definitely greater, Definitely greater you should get. 25 divided by 15 into 30. I am getting 50 centimeters. Very good. Superb, Raju. Next question. Question हो गया क्या? Question 85. It seems completed all the questions. So this is my telegram. This is my telegram link, electrical by Naveen_Gollapalli. You can search in telegram channel like this. Naveen_Gollapalli. Electrical. Join me here and ask me if you have any doubts. Ask for doubts. Why do you want to join here? Ask for doubts. Any study material if you want, ask me. Any updates you want, ask me. So these things you can ask me, you can reach me. Yeah. Okay. Right. Clearing doubts, and if you want any PDF notes of any class, notifications regarding updates, new exams and upcoming exams, and any information updates, upcoming exams, daily I'll try to, earlier I used to post the questions and I used to post the quiz. Now definitely I'll start posting the questions on daily basis, and I'll start posting some concept oriented questions also, okay, in this channel. Right. Chalo. 2020? You want 2020 paper also? You want 2020 paper? 2020 HPCL, did they conducted HPCL questions? I do not know, but if it is there, we will look into it. If it is there, we will look into it. Raju? Sure, we will look into it. Thank you, one and all. Have a nice day. Bye bye. Raju, you are a paid member. So, so how can I help you? Raju, please tell me. Tell me, Raju, like, what do you want? Tell me, please. If you are a paid member, then that's fine. In AEJ, no, as of now, no, because so many people are there, no, already. Nitin sir is there, Ashish sir is there, and Chetan Kumar Sharma also there. So many faculty are there. Why me? Okay, you prepared for SSC, JEE and RRB work. That's good, fine. Okay, okay. Done. So aim for RRB JEE. I think RRB JEE notification came, right? RRB JEE, SSC JEE. So, all right. Then. Wish you all the best, Raju. Oh, Raju, 2020 student. Ah, okay, 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 okay. I'm not able to recall you. I'm so sorry, Raju. I'm so happy to see you here. I think I taught you measurements. Then it's okay. Okay, fine. If you have any doubts, you can please reach me on the Telegram channel, or otherwise uh, mail naveen.gollapalli@byju's.com. You can reach me. Right. Thank you. Thank you, one and all. Have a nice day. Bye bye. See you. See you with another beautiful session.